ArcGIS Velocity is part of ArcGIS Online. It's therefore software as a service. Free overarching capabilities. It allows you to ingest feeds of information, regardless on that feed's protocol or the data format or the rate of data that's coming through that feed. With this ingested, you can then break it up into either real-time analytics, where you perform essentially analytics on the fly against the events that are coming through that feed, typically used for alerting and notification workflows, such as incident detection with geofencing. But then you've also got big data analytics, which allows us to look at the bucket of spatial temporal data that you've collected and look at the last 30 minutes or the last hour or the last 24 hours of data and uncover trends in that data to present to your end users. With a feed, you can connect to these, and with a real-time analytic, it gives you that immediate awareness of incidents. You also have the option of persisting the events as they're coming in to disk, and that can be a feature layer, it can be a spatial temporal layer, it can even be cheaper stores such as S3 or Blob. Once you start to persist this data, what I'm trying to get at is, depending on the velocity of your incoming feed, you can start to accumulate quite a large amount of data. And velocity has been designed to grow with your organization's needs. So you can actually either set up data retention workflows where you only keep the last 24 hours of data in a rolling period, or you can start to set up persisting the older data to cheaper stores like S3 and Blob storage. And regardless of where you're persisting it, a big data analytic can be set up to look at that spatial temporal data and run a series of analytics to uncover whatever it is that you need to know to solve problems. And these big data analytics, they can look at the last hour of data, last 24 hours of data, whatever you need, to do things like hotspot analysis or generating track lines or calculating dwell spots. And then whilst these big data analytics can be run ad hoc, the real power is running them as a scheduled process. And what I want to get to in this session is how you can combine both of these together and the information products that both of these analytics will provide, and use these in downstream interfaces in this context for an emergency management situation. The spatial temporal analysis, there's a whole range of different processes that we can tap into. And we'll be using a number of these, and you can string together these for whatever business problems that you're trying to solve. And today we're going to use a real data set, some GPS location data from ground and air units in Victoria for a couple of weeks back in 2014. This radio data, we're essentially going to use it to fake a live feed, and we'll trickle it through as if it's a real feed happening, and we can perform some real-time analytics on it that will create some information products as layer items. And then also simultaneously, as we start to collect the data, we'll grab this data and perform big data analytics. In this case, we're actually going to perform it on the CSVs that are being stored in Azure Blob Storage, and we'll do a range of other processing on that data to, again, create additional layer items that are near real-time information products. And both of these can be mashed up together. In this case, I'll do an ArcGIS dashboard, but it can be whatever applications downstream that your users will need for their, again, it's a common operating picture of both during an event, post an event, but having both of these kind of working together to give you some information. And ArcGIS Velocity is what's going to help us make that happen. This web map is showing a bushfire, an active bushfire around the Rocklands area. And all of these layers are outputs from a real-time analytic. It's going to be easier for me to actually show that real-time analytic on the right here. So first thing is a feed. It's connecting to typically an API, but in this case, I'm connecting to a CSV file and iterating through it line by line to get the GPS data and all the other data to pretend like it's a real-time feed. With that, it gives me a stream layer to visualize where these locations are by these vehicles. I'm also on the fly calculating VicGrid. So the incoming feed is in WGS84. The rest of the map, including the bushfire observations, are in VicGrid. So on the fly, create that, reproject those locations as VicGrid, and then calculate distance between the vehicles and the bushfire observation layer when it's closer than 1 kilometer. And this allows me to use it to essentially, in this case, just label how close they are, or in fact within the bushfire front itself. That can be used for downstream alerting purposes if required. What else have we got going on here is the Geofence one. So this is a incident detector to detect when the vehicles enter the bushfire front, the active bushfire front. It'll create an entrance point for each of those and tell me which vehicle was it, how fast were they going, at what time did it happen. And that can be used, in this case I'm persisting it to a feature layer. Maybe you want to use that in a dashboard widget or another BI tool together. And at the bottom, a useful one is detecting gaps. So in this detecting gaps, it looks like I haven't actually got any at this point, but this detect gaps, it'll look at the unique vehicles and in this case, they've got a designator ID. And if there's a gap of an hour between them dropping a GPS breadcrumb, it'll trigger for a gap alert, and a feature will be created at that point, or the last known location on the map. If I let this demo run through the whole file, you'd see a few pop up. In this case, there is none at the moment. So that would calculate those. And again, in this case, we're outputting it to a stream layer that's currently empty at the moment. So this web map is showing some layers that are the result of a big data analytic that's shown on the right there. This big data analytic, it's not connecting to a feed of information, it's connecting to a data store. And this data store happens to be a CSV file with all of that GPS location data. And it looks at that as a whole. It doesn't look at it event by event, it looks at it as a whole data source. This runs a series of different operations. So on the map in the left, taking a step back, using ArcGIS Living Atlas, we can hop on and actually look at the Landsat data to actually get an understanding of where the latest scene, or in this case, a historical scene of where that bushfire extent went to. That's just a good sort of drop of how the Landsat data can be easily added to your web maps. We can look at the actual active bushfire location itself, and this is a temporal layer, so we can sort of play through this as required. And we're actually looking at the raw vehicle positioning feeds. This is the actual GPS location data. And I've chosen a very slim slice here just because I know there's a lot of location data in here. And a better way of visualizing that data when you start to deal with larger data sources or larger time windows is to just simply aggregate it. And this aggregate, you can specify the size of the bin and the time step that you want to kind of break those bins into. In this case, we've just done some fairly large bins that, if we then look at those bins, allow us to actually really sort of slice and dice into the time extent of that bushfire and understand, well, look, how did the bushfire extend and what was the activity around that bushfire at that point in time, be it a large time window or a small time window. You kind of get to control that visibility. So just aggregating data can be quite a useful way of understanding how your feeds may have been what they would have been visualized like around, in this case, a bushfire. So here, it's not until about this point when they start to actually respond to the event. Reconstruct tracks, that's a useful tool on its own to just understand the kind of the locations of where the vehicles went, sort of see the directions they were heading. Another tool you can actually use, which I haven't used, but you can snap to a road network first. So in this case, a lot of these fire roads won't exist in the network data that I have, but you can snap it to a road network and then do generate tracks to kind of really understand exactly where they were going and then count up that data. Find dwell locations I felt this was a really interesting one. So this allows us to understand, okay, so around this bushfire, when vehicles were within a 300-meter distance of themselves for longer than 4 hours, we consider that a dwell location. They were hanging around in that particular spot. And using their unique ID, we can sort of work out where those are. And we can either generate the mean centers, or you can actually generate convex hulls, which is what I've done here. So these are the dwell regions. It's where vehicles were hanging around for, in this case, 275 minutes, with a mean distance of 144 kind of meters in that convex hull area. And you can start to say, well, look, this might have been active areas people were responding on, or maybe there was other reasons for those vehicles sitting around. Maybe it was fuel points or water refill points, things like that. And then up on the bottom here is just a simple spatial temporal join. This allows us to calculate those vehicles in the bushfire. So we can see, depending on the slice we're looking at, where there was points where vehicles were in the bushfire, and again start to understand, well, which vehicle was it and at what time was that particular incident. And The idea is that you would schedule these real-time analytics to run as often as you require, and you have the real-time analytic that's always kind of operating on the fly. And then you would pull together the various information products that you need into your own dashboards or your own existing interfaces where you visualize this type of data. So here we can see we're looking at the live vehicle positioning feeds, but actually we can turn that off and start to look at that same aggregation data we were seeing before and start backtracking through the last set of days and say, okay, what was happening on the 5th and where was that data? What was the average speed of the vehicles? Compare it to the 4th and okay, there was some dwell sites. Well, start to click on where those dwell sites are. So that's really the point I'm trying to get across here is you can use both the real-time analytics and batch analytics or big data analytics to provide you the necessary information layers that are going to be useful for, in this case, an emergency management workflow, but it could be, your field crews just operating around work sites and understanding how many work orders they're doing and what's the last day of activity been like versus their current actual activity.